Here's an electric field pattern around an isolated positive charge and an isolated negative charge. These are radial field patterns. And here's a uniform electric field pattern, which is between two parallel plates. Now I'm asked to draw the electric field pattern around two charged particles. They're right next to each other. The magnitude of the charges are equal. Okay, to figure out what the electric field pattern looks like, I'm going to pretend to be a test positive charge. The positive particle on the left is going to repel it, and that force acts away from the center of that positive particle. The one on the right is going to attract it, but because that one on the right is further away, it's going to be a smaller force. Okay, then I'm going to add these vectors tip to tail to figure out the resultant, and the resultant is towards the top right in this case. Okay, let's repeat this process at a different point. The negative charge particle is going to attract it with quite a large force because we're right next to it, and it's going to attract it towards its center. And the positive particle on the left is going to repel it, but again that's further away, so it's a bit weaker. Adding these tip to tail and get the direction of the force well. So if you repeat this process for multiple points along the field, around the charges, you get a field pattern that looks a bit like this. So as you can see, it's got the V lines are pointing away from the positive and towards the negative, because the electric field points in the direction of positive charge particle to experience the force. And if you look very closely near the particles themselves, in these regions I've highlighted here, it actually looks a bit like a radial field. So there's a combination of the radial fields from both of them together. Example 2 here, the diagram shows an electric field around two objects. Compare the charge of the two objects. Okay, let's start with the direction here. Okay, so if I was a positive charge particle over here on the top left here, the force would be towards the top left because I'm being repelled. So that must mean QA is positive. Let's try again at another point here, and I'm being repelled again towards the top right on this side. So that must mean QB is also positive in order to repel it like this. Okay, so they're both positively charged particles. Okay, but the magnitude of the charges are not the same. As you can see, it's not a symmetrical pattern. So let's take some point in between, let's say around here. As you can see, the force is a larger force towards the top left rather than towards the top right. So that's because the field, the charge on the right has got a larger magnitude, because the charge on the right is more positive. You can also tell this by the number of field lines around it. The number of field lines and the closeness of the field lines is greater near the charge on the right. So the magnitude of charge on the right, charge B, is greater than the charge on the left there. Final example here, the diagram shows a negatively charged ball near a long flat surface. The surface is positively charged. Sketch the electric field pattern in this setup. Okay, I'm going to pretend to be a positive charge. Let's start with this point over here. I would be attracted towards the negative charge because I'm closer to that negative charge. So that would be pointing towards the center of that charge like that. Maybe slightly towards the right because of the repulsion from the left. If I was on this side, then again the main force is going to be an attraction towards the center of that negatively charged particle. If I was down here, I'd be attracted like this. Okay, and then what about closer to the surface of the positive surface? Here, the dominant force would be a repulsion towards the right. There may be a slight attraction downwards towards the negative ball there. Okay, and if I was on the bottom side here, it'd be a bit symmetrical. This setup is symmetrical above and below the charge there. So it'd be a force like this with a slight attraction upwards because of that negative charge there, but mainly repelling from the positive plate. And if I was in the middle here somewhere, then there'll be a very strong repulsion from the positive plate and attraction towards the negative charge particle. So it'd be quite a large force towards the right. If I join all of this up, the electric field pattern looks a bit like this. As you can see, near the negatively charged ball is a radial field, and near the flat plate actually looks a bit uniform, but it's not really uniform. As you can see, near the center, it's a bit stronger. The field lines are closer together, and it's a bit stronger over there.